All right, we're back. We're going to be working with students. This is a class that we developed in the last video. As always, I invite you to code along with me. Don't just watch the video or look at the source code and think you got things figured out. We're going to ultimately add in more constructors. We're going to overload the constructor in this video, and we're going to implement a toString method. So let's get started. Here I am in the student class. I got 4 instance variables, right? Each instance variable represents a single property or attribute, something like a first name or a last name in the case of our student. I also have an integer that stores my ID, GPA, that sort of thing. These 4 instance variables collectively make up the object state. We then see a constructor. This particular constructor doesn't take any arguments in, and it does what constructors do, which is set the initial state of the object by initializing the instance variables. These instance variables, they are declared in the body of the class, but they don't have a value. Right? It's the constructor that gives them their initial values. Then we have these methods. Right now, it's just a bunch of getters and setters. Right? Ways to access and modify these instance variables from another class. Right? We also talked about in a previous video why these instance variables are private and why accessors and mutators, these getters and setters, even exist. In our driver, we ultimately made 2 students, and that was one of the highlights of our last video, is showing that we can make multiple objects. Right here I have Stu, which is referencing a student, and I can come in and I can modify Stu. In this example, we're changing the name to Jerry, and we can see that change. I made a separate student in the same scope. Right? The moment that I create stud, Stu still exists. Right? We actually end up referencing Stu down here, which still exists. And so these objects can exist in the same scope independent of one another, which makes sense, right? In the case of something like a student, maybe you're going to make a grade book. You're going to have like 30, 40 of these things. If you're a whole school, you got thousands. So we're going to pick up there. And the first thing we're going to do is something neat. We're going to overload the constructor. What do I mean? Here you see I have a student constructor. I'm going to come in here and I'm going to say public student. Now, if I just stop there, I have constructors that are the exact same. Their signatures are the exact same. You can't do this in the same way that you can't make methods that have the exact same signatures. So what you can do is overload it. Right? I have a constructor, student. I'm going to create another constructor, student. But this one is going to take in some data. It's going to take in some parameters. In particular, I maybe want to take in a string for my first name, a string for my last name, and how about an integer ID? Maybe new is not a good thing here because they're actually just going to start out. How about you do like string F, string L, and int I? Also not great. More on that later. But take a look. IntelliJ is not mad at me. Here I have student. This is a constructor. How do I know it's a constructor? Well, probably most importantly, there's no return type. It's got parentheses, which makes it look like a method, but there's no return type. Also, the name of the name of the constructor matches the name as defined in the class header, including the capitalization. Down here, I have a constructor. How do I know this is a constructor? Well, it looks kind of like a method. It's got parentheses indicating that it can take in parameters or arguments, and indeed, this one actually does. But that being said, there's no return type here. Right? Those are like the 2 ways that you can tell. There's no return type, and the name of the constructor matches the name as defined in the class header. Okay, so this is a constructor. I effectively have 2 constructors. I am overloading the constructor. This particular constructor takes in some values. Instead of using these default dummy values, right, John Doe and 404, I'm going to use these parameters to actually set the initial values. Right? I'm going to set first to F. I'm going to set last to L. I'm going to set ID to I. Now you'll notice I have 4 instance variables, but I'm only taking in 3 parameters. And that's okay. Maybe your constructor doesn't take in values for everything. Now, we still need to initialize GPA, however, but this is kind of an example of like a pretty good use of this constructor. Think about this. You have a new student enroll into your system, or you're adding a new student to your gradebook. Things like first name, last name, and ID, those are integral to the student. They're coming with the student, right? They already have those things. But maybe GPA is something that's not established. Maybe they're starting with a default GPA of like 4.0. What I'm really trying to communicate here is that just because we have 4 instance variables doesn't mean we got to take in 4 values. Okay? You can kind of mix and match, and it depends on the context of your program. Okay. We have overloaded this constructor. What does that allow us to do? Let's hop back over to our driver. I'm going to get rid of this stuff. Let's make a new student object. I'm going to create stu, but this time, instead of using the noargs constructor, right? Take a look, IntelliJ's happy. This is valid syntax. This noargs constructor still exists. Instead of doing that, I'm going to include values here. Right? We have a constructor whose signature takes in string, string, int. I'm going to call that constructor right here by passing in string, string, int. Let's use something other than 404. Right, keep in mind this little syntax here, right? This little F colon, L colon, I colon. What IntelliJ is doing is telling me what I called the parameters here. Right? I did not type this text, right? That is just helpful reminder text. Okay, so we're calling a student constructor that takes in string, string, int. Whenever this executes, it's going to jump here, and it's going to start executing the stuff. Well, we're going to save in F to first. We're going to save in L to last. We're going to save in I to ID, and we're just going to set the GPA to a default value of 4.0. So this is creating a new student. Let's see what these default values are, right? If I come in and use some SOPs to maybe grab stu.getFirst. Maybe I'm going to grab stu.getLast. Maybe I grab stu.getID. And lastly, we're going to do stu.getGPA. Let's see what these initial values are. I'm going to right click, tell it to run. I could have hit my play button. But we end up with Bob Jones, you know, like it's these values that I provided. These values went in via the parentheses, and we ended up using those values, F, L, and I, to initialize these 3 instance variables, and then just used a default value here. Okay? Let's overload another constructor, and then I'll explain why you even want this. Right? We could keep going with this. I can do public student, and this time I'm going to do string F and string L. I'm going to do a parameter for each instance variable. Okay, this is pretty common, right, to have a constructor that takes in a number of parameters with the correct data types that correspond to each instance variable. And all we're doing is saying that first is F and last is L and ID is I and GPA is going to be G. Right, back in my driver. Maybe I come in here and I make stud in the same scope. Close my parenthesis too early. So I'm going to create a new student, and I'm using the constructor that I just made. How do I know? The signature matches. I'm calling a student constructor that takes in string, string int double. Here's that constructor, string int double. It's going to do its thing where it saves in F, L, I, and G to respective instance variables. And I have now created this new student, and I can go through and print off the data about it and see the initial state. Why don't I just do like one or two things? We'll just do the whole thing real fast. I'm about to do something real big brain. Okay, let's check out the values for this new student, which is actually saved in the variable stud. I've told my program to run. It's processing, and there is a different student. Neat. What's the point? Well, the point of this is we're ultimately giving options to our client classes. Client classes are anything that uses this code, the student code. The driver is a client class of student. What we have done is given client classes, such as the driver, 3 different options on how to set up the initial state of the object. Maybe we want to make a student object and we only know a little bit of the data. Right? Maybe we don't know any bit of the data and we just want to make a placeholder student. And well, that's where the no args kind of makes sense. Maybe we know every bit of the starter data, the initial data that we want to initialize the object with. Maybe we know all 4 instance variables. Well, we can use this constructor to kind of set that up. The point is we can overload constructors to give client classes more options. That's it. That's the whole point. Okay? So that's going to bring us into our next topic, which is talking about the toString method, because in practice, accessing the state of an object occurs frequently. What are we talking about? Well, state, a single instance variable corresponds with like a single property or characteristic, right? And my student first corresponds with like a first name of the student. That is a single property, a single attribute about my student. Collectively, all of the instance variables make up the state. In the case of my student, we're talking first name, last name, ID, and GPA. So when we talk about accessing the state of an object, we really mean accessing all of the instance variables. Having to call several accessors each time you want to know about the state of your object is not practical. What am I saying? Here in our driver, we did just that, right? I created a student. I wanted to know what the initial state looked like. What is the first name, last name, ID, and GPA? So I have to call each of these accessor methods, okay? Imagine we come in and make a change, right? Imagine we come in, we take Stu, and we set the first name to Bobby instead. In order to see that change, right? In the case of set first, okay, I probably have edited the first name, so I want to see what the change to the first name is. And so I call the accessor method for that. Okay, now here's something I kind of want you to imagine. This is pretty straightforward, right? I see the first name here. I make a change to the first name. I get the first name. But what if your accessor method, your mutator method, what if you have a mutator method? Maybe it's a little bit more advanced than just a simple setter. Maybe it's actually modifying multiple instance variables in your state. Are you going to call all of those things? And what if you're like testing the program and you're not sure which instance variables are being modified? The point is, we need a quick and easy way to see the entire state without having to call all those accessor methods. In practice, we use something called a toString method. This is ultimately a convention. Each of our classes will define a special method known as the toString method. ToString is going to return a string representation of our object. That's a real loose definition. What we're talking about in practice is returning the object state. That is, all of the instance variables. This is going to give client classes, like our driver, the ability to access the state of an object by simply calling one method. Here's kind of an example, right? We have public, we have a return type of string, the name of the method is toString, we're not taking in any parameters. No additional data needed to do this. This is ultimately an accessor method, right? I'm going to asked this question probably at some point, but would you call toString an accessor or a mutator? This is an accessor. Why? It's returning information about my object without modifying it. Here we see an annotated string, right? I got a string literal concatenated with first, last, ID, these variables. And I'm just concatenating it at the point of return. Right? We're saying our first name is this, our last name is this, our ID is this. GPA is omitted just to fit it on the slide here. Student's toString method can then be called by a client class, such as our driver, to access all of the information pertaining to the state of the student object. Here I'm creating a stu. It's a new student. I'm passing in John Doe 23. We're calling one of those overloaded constructors. I then am taking stu and calling the toString method. This returns a string. It's all of this information. I'm storing it into a variable called state. I can then print that out. Let's write this toString method and let's test it out. I'm going to flip over to my student. It doesn't matter where you put it as long as it's in the body of the class, but typically it's the very last method. I'm going to do public string toString. We want to return information about the state of the object. This returns a string representation of the object. AKA returns the state, all of the instance variables. Something like that. Okay, simply at the point of return, I'm going to do a string annotation here, right? We're going to say first, and we'll tack on our first name. We're going to say last, and we'll tack on our last name. Now, I like to spread these out over multiple lines, even though, as hopefully you'll see, this output is all going to be just on one line. So here's our first, here's our last. We would then next do maybe ID, and then our GPOP. That's it. I got 4 instance variables. Here's all 4. First, last, ID, GPA. Collectively, they are the state. What is the point of this? If I flip back to my driver, instead of doing this, right, I can just very easily, we'll do it down here with stud. How about that? I'm going to comment out stud. All those methods there. We're going to create a string. I'm going to call it state. And we're going to call stud.toString. I'm then going to print off that variable. Right? Here, stud gets created. These values get set in the constructor. I want to see what those values are. So I'm going to call the toString. It's going to give me all of it. First, last, ID, GPA as a string. I'm going to save that into my state, and we'll be able to see that. We're going to see some stuff about stu to begin with, but at the end, we're going to see this annotated string. It's like a one-stop shop for all of my stuff, right? First name, Jennifer. Last, Garner. ID, 505. GPA, 5.0. Okay. We could shortcut that a bit, right? I don't have to save it in a variable. I was more so showing that it returns a string. So back in my code, I could just inside the SOP do that there. And we're going to get the same result. All right, this toString method, it returns a string. This string in particular. So right now, this toString concatenates the annotations and instance variables together in one line. I imagine almost every person that saw this was just like, whoa, that's hard to read. What would be sweet is if we could spread it out over multiple lines. In some situations, it's desirable to space out the information across multiple lines, right? So right now we got something that looks a little bit like this. I want it to be something like this. In the past, in order to make new lines, we used SOPs. We used SOUT, system.out.printlines, in order to achieve that. While it would be syntactically okay to add SOPs into the toString method, such a tactic is against best practices. What am I saying here? Right? We're supposed to return a string. I could design this in a way that instead of returning a string, it prints here. But that locks us into that. We actually have more flexibility leaving this as returning a string, because then we can decide what to do later on the back end. So it's not a good idea to put system.out.print lines in these things. Java, fortunately, has these special characters. Almost every high-level programming language has these things. They're called escape sequences, or just escape characters, that can be used in strings to achieve certain effects. The one that we care about the most right now is \n. Right, this is a backslash because it's leaning back. On your keyboard, it should be above the enter key or near the enter key. So that'll create a new line. This will create a tab. Tab's a character. Single quote. That's important if you're trying to, right? If you're making a string and you want a literal single quote to show up or a literal double quote to show up in your string, this is how you achieve that. What if you want a literal backslash, right? Because the backslash is the escape character. Well, there's an escape sequence for that, right? This will allow you to generate a single backslash in your string. Some of these are kind of like quirky. It's like, oh, okay, that's clever. I can see why we need that. We're going to use this new line one. Right? We could throw this in to our toString. As it turns out, these escape sequences or escape characters are just that. They're actual single characters. Here it's demonstrating that I could put these things in single quotes despite the fact that we see two characters, right? The backslash and the n. This is treated as one character. Okay? I can save that into a char if I wanted to, but we could just make it part of our string. The new line escape sequence can be used in the middle of a string to generate a new line. Here's an example, and this one's a little bit wonky. We'll space it out a little bit better so it's cleaner, but I have a string, str, with the contents, hello world. But in the middle of that, you see this backslash n? That's my new line escape sequence. What is actually created by this, we can see it whenever we print it off, is that we have hello, comma, then our new line, world. We can use these new line escape sequences in our toString. They're just characters, and change the formatting of the return string. Something like this. Right? I have first and then our first name. It's just first in our program. Let's update this slide right now. So maybe I have first and then we include our first name. I have last and we include our last name. But you see these new line characters? What that means is as soon as we get done with this, there's a new line. And then there's a new line. Right? You can do it this way where you just include it as part of the string. I like to make this as clean as possible, and I like to tuck my new line characters towards the end. Right? This is extra. I could plug it in down here as we saw with the previous slide, but I like to separate it because what I end up with is something that looks a little bit cleaner here when I'm viewing the source code. This is a single character. I have it in double quotes here. It's a string at this point, but it's a string with a length of 1. There's only one character here technically. Let's implement these things, and I think you'll see what I'm getting at. I'm in student. Here we are with the toString. I'm going to plug in my new line characters, and again, I like to do it here at the end because it makes my code look a little bit cleaner. We're going to have first show up on its own line. We're then going to have last show up on its own line. Our ID will show up on one line. And then our GPA, we could choose to put a new line here or not. It depends on what we want the next bit of stuff to show up as. Maybe that's a good idea. Let's go ahead and do it. Let's try this out. I'm going to run my driver. And we call the toString method here at the very end on stud. And there's that information. There's actually a new line here. I ended up with 2 because the print line is actually making a line, and I have a new line being created by this escape sequence. So maybe I don't want that. It doesn't really matter. It's like a little formatting visual thing, right? It's how you want the data to be presented. But this is way cleaner than putting everything in one line, and we're able to do it because of escape sequences. Now, there is special functionality built into Java to encourage you to use these toString method, right? I said it was a convention. That's true. Like, there's no syntax. If we look at this, it's not like toString is a reserved word, right? If it was a reserved word, it would look the same as public or return or double, right? toString is not a reserved word. This is a convention. However, that being said, there's incentives in Java that encourage you to write these things. And, you know, aside from us having one method that just gives us our entire state. For instance, an implicit call to the toString method is made when an object variable is specified as an argument in an SOP. That's a lot. Let's look at an example. Right? Here I have Stu. Right? We're creating a new student using a constructor. Then we have these two print statements. That's system.print line. This is explicitly calling the toString method. We're doing stu.toString. However, this is the incentive that's provided. You could just do system.print on the object, and Java is going to implicitly call the toString method for you. Let's show that. I'm going to flip over to my driver. Right here, there's stud. I'm going to get rid of this explicit call to toString. I'm just going to try to print stud. I want you to think about that for a moment. Like, if I'm trying to print the object, what is there to print? Java is making an implicit call to the toString method. Maybe that's a good comment. Right, we're actually calling stud.toString, and I just ran my program. We see that here. Right? Maybe I want to do the same thing for Stu. I'm going to do a sout on Stu. And again, it's going to implicitly call the toString method. That is an incentive that has been programmed into Java to encourage you to write a toString method. Likewise, an implicit call to the toString method is made when an object variable is concatenated or is referenced in concatenation. Let me show you this, right? We're creating a student. We then have these statements down here. I am trying to take a string literal and concatenate it with stu.toString. Well, the toString method returns a string. So I'm trying to combine a string literal with a string. And I'm saving the result into a string. Okay, that makes sense. What I'm saying, the incentive that exists for you, is if you take that string literal and you try to concatenate it with stu, just the literal object, here again is going to be another implicit call, right? It's going to actually do the same thing. These things are functionally equivalent, right? That's a good way to maybe, you know, list out the variable, right? This is going to be this particular output is Stu. I guess that's a little bit misleading because it's actually in the SOP, but if I were to create a string variable and save this stuff in and then print out that output, we'd get the same result. Okay, notice IntelliJ is not mad. This is perfectly good syntax, but it's a little bit weird because what this looks like is I'm trying to add or concatenate a string with a student object. Those things don't normally go together, but what's happening is we are making an implicit call to stu.toString. And I see that here. Maybe a big brain thing would be use an escape sequence. So that we get Stu, and then all the information pertaining to Stu. So those are two incentives that Java provides to encourage you to write a toString method, which is ultimately just a convention. That's the end of student. I'll see you on the next one.